So my name is Rob. I'm on the product security team at Uber. Was recently engineer and transitioned to management about 6 to 9 months ago. So please don't ask me any management questions. But besides that, we'll dive in. The goal is kind of to go through and give a storyline of how a bug can go or report through bug bounty, and then kind of more focus on the type of return we see on bug bounty besides just one-off fixes and stuff like that. So let's see. Perfect. Live report. This is what we're going to go into. So essentially 3 stages for the various things I want to highlight for this talk. These can be further broken down, but that detail is not really necessary here. So we'll dive right in. So first response, the biggest important thing we get from here is identifying the critical vulnerabilities like as soon as possible. There's some other benefits from having really good first response time, but mainly we want to see the worst bugs as quickly as possible, and that's kind of our focus. The various influences at this stage are essentially how easy it is to reproduce. So being able to click one file, know it's a bug, and file it internally, that becomes really fast for us to get filed with an internal team and get fixed and things like that. If we have to spend a lot of time going back and forth with the researcher, or it's not clear if this is reproducible or actually a bug, then we obviously have more time to figure out what's going on exactly. And then there's also the time of day when it was filed, right? So Friday at 6 p.m. is going to have a much longer first response time on average than something that gets filed at 10 a.m. on a Tuesday. So that definitely has an effect, and first response is probably the easiest stage of bug bounty, so there's not much more to say there. Cool. So validate, the biggest takeaway here is understanding the security impact, and that kind of ties back to how we award bounties and stuff like that. Very much don't get into cleverness or how complicated your exploit is, and really just boil it down to the exact security impact of what you're reporting. And so for that reason, this stage is pretty important, so that before the bug is fixed, we know the security impact, because we can't go look at that point and reproduce their thing and see what kind of data is exposed. So doing that at this stage becomes pretty important. Some things that influence this, again, reproducibility of the report is just like the first response phase, but also the amount of back and forth between the researcher. There can be a lot of challenges there, but if we can minimize the amount of back and forth, then we get faster turnaround, and that makes validation a lot easier. Let's see. Ability to test. Actually, somebody was just talking about this earlier. So we have products globally, and so you can imagine there are situations where we have certain features turned on for only certain markets. So for example, India, we have very specific pay with cash and various other features that aren't available to the rest of the world. And so it can be challenging during the triage process when you're validating and things like that. If you don't have a test account that is very easy to get a hold of and do this testing immediately, at that point you have to go in and find internal teams and stuff like that. So let's see. Boom. Ensure and verify. Okay, so this is obviously the most important stage. We actually get the thing fixed. Some of the influences here, finding an owner can sometimes be more challenging than expected. We have a product security team, about 12 people. We have about 2,500 engineers. Scaling that is a really crucial part of bug bounty programs, and finding an owner is part of that as well. Complexity of the fix. Sometimes from the outside, something can seem seemingly very simple and should have an overnight fix. But depending on how it works out internally, and especially amplified with microservices and things like that, the fix can actually seem to be simple, but can take a long time based on the complexity. So that can sometimes cause the fix getting to land take longer than either the researcher or our team would like. And then validating the fix. So we have developers fix these things, we guide them, we take it as an education opportunity. I'm going to dive into that a little bit more. But the most important thing here is developers are not security engineers. They're not supposed to be security engineers. So our team and the researchers validating that the fix they wrote actually does fix it is a big, big part of making sure that this is fixed and we don't leave it open because they forgot to put a Q on the end of something and didn't consider that corner case or something like that. So cool. Oh, yeah. And then we pay them money. So cool. So now we're going to kind of dive into the value of bug bounty. It was brought to my knowledge, not a lot of people know what a divining rod is. It magically finds you water. I think that bug bounty can be used in a similar way to kind of find where you need to focus on your team or education or various other things like that. So we'll kind of dive into framework, shims, education and engagement, and the team aspect here. So frameworks, essentially a framework is a library or some set of code you hand developers that makes security easy for them. Again, these people aren't security engineers, we're the security engineers, so when we can write a framework that we hand to people and becoming secure is easy, and they just have to call a function, that makes it much, much easier to prevent bugs and get this adopted in a way that we don't continue to write the same class of vulnerability. So it enables our engineers to be secure. We solve an entire class of vulnerability by writing some little bit of code and handing it to all the engineers for them to use. You get secure by default. So you can imagine we have various scaffolding to roll up a web page. And that is made to be as simple as possible. So engineers can just click buttons and get a service. Making sure we fit in security in there so that when they click buttons and get a service, they get everything for free is a really big part of just stopping the bleeding and making sure as we go forward, as we identify new things, we don't let them spread through our code base. And then we try to make insecurity hard. So sometimes the naming of functions and stuff like that is not entirely obvious what you're doing and whether or not it's safe or dangerous. And these are not things we write. These are things out in the public, maintained by the world. So when we write our frameworks, we try really hard to make it obvious what you're doing, especially if it's dangerous. Most often it says remove all security or this is dangerous and things like that, to kind of call out that they don't do anything by accident based on not entirely understanding what some vague function name is. So, all right. Yep. Sweet. So secure shims. This is kind of something we like to do when we can. The cases, you don't get to do it all the time, I guess is my main point. But the idea here is we shim in security for all of our various services and they get it for free. What's great about that, obviously, they don't have to do any work. They don't even have to know about it. We just kind of put in some security software at the edge. It does some things and it gets sent along to their service and they don't even have to change any code or anything like that. Makes it really easy for other developers to adopt it because they get it without knowing. So that makes adoption fairly easy. And then the other thing is it doesn't require a change to end services that might need this new security thing. So you can imagine if we had to get it across 100 different services, you'd have to go touch 100 different code bases, get 100 different teams involved to get something updated. Whereas this, we can just kind of shim it in before that and they get it all for free and don't even have to go bother them or anything like that. Let's see. Yep, I think that's it for there. And this becomes one of the bigger areas that we see a lot of advantages in. So you have an immediate engagement with the author of the vulnerability. I mentioned earlier we have about 12 to 14 person security team, somewhere around 2,400 engineers. We're not going to be fixing all these because we just can't scale. So what does happen is you go find an owner, assuming you can find one, and then you sit down and talk with them about what is wrong in this exact example, what they did wrong and how they should fix it. And then they go through and fix it. And then the validation step we talked about, making sure their fix works, is kind of a loop until it does work. And you just keep getting to tell them about how what they were doing was insecure. So it's kind of an immediate education opportunity with the person that wrote the bug, right? Which is maybe the most important person that needs to learn about this kind of stuff. So, and then generally speaking, it kind of, I think somebody else mentioned it, kind of gives you an idea of where to focus education for the entire org, to try and, once you see a pattern of various things that people are doing insecurely, we can spend a little bit of time on that in our education, write a hands-on lab or something like that to give people actual experience in this thing that we see a lot. And without bug bounty, it'd be much harder to kind of focus in that energy on these various problem areas. Let's see, what else do I want here? Yeah. So in bug bounty, when things are found in bug bounty, it's oddly interesting to developers because it's publicly known, right? At that point, the things our team finds, they don't consider to be publicly known. So what's cool about bug bounty is when you have a bunch of good stories from the various bugs that were found, it gives you an ongoing opportunity to re-engage these people with cool stories. And then they're like, oh, this is awesome. This was publicly found. And it's a way to suck the engineers back in, even if this wasn't a newly found vulnerability that day or something that they needed to get fixed or something along those lines. Education, kind of a twofold. Our treasure map's been mentioned previously. That's kind of education focused on the researcher side. And so as we go through bug bounty, we see better ways to educate the researchers to try and bring up that community in general and stop getting reports and unnecessary back and forth on misunderstandings and stuff like that. And then the final thing is our education focuses really hard on these developers are not going to be engineers or security engineers. So we try not to make them think they should be security engineers. The most important thing for them is to identify when they should be reaching out and how we can help. We don't want to give them enough knowledge for them to shoot themselves in the foot by thinking they know the right answer without engaging the security team. So it's a hard balance on how much you teach them on identifying the issue versus what the actual fix is in a broad context of giving education to everyone. And let's see. Cool. I think that's pretty much it. And then team. There's no better way to learn than to teach. Dealing with people that have misconceptions about the security impact of their report or simply just don't understand the things they're poking at. It takes a lot of patience to explain that to them. It's important and it's the right thing to do. But that can take a lot of patience, and having to explain something to somebody, in my experience, and I think this quote is true, is kind of makes you take a step back and explain your assumptions that you would normally not explain to somebody that you expected to know certain things. So that's really good for our team in general to get that practice. And then when we have to do it internally with other engineers and stuff like that, it comes a bit more naturally. And then recruiting, I think everybody has kind of already hit on this. It's a great way to find new talent and try and get people in for the team. Hiring for AppSec's really hard. And as an anecdote, I also got my interview at Uber through responsibly disclosing a few bugs before we had the bug bounty program. So it works good for recruiting, I guess.